Well, hello, friends. Today we're going to work a little bit on libhtml again, because when I was using it a while ago to use in the IRC client, I ended up feeling like I wish that it would have some kind of way to give it some HTML and it will create a DOM tree out of that. And what I mean by that is that I'll show you that we have this thing here where we add stuff to the window in an IRC channel, for instance. Then we have to build up this DOM here where we say like first create a div and then give that the style attribute and then create a span and then do some stuff with that and like we just create all these elements and put them in a tree together. And it would be so much cooler if we could just let's see, we'll say create a fragment, Parse HTML, and we'll say something like just like this, right? Div style color. We can do it this way actually. Or let's use a string builder to build the HTML because that will be a bit easier. But you already get the idea of what I want to achieve, right? Like I want to turn this mess down here into something much, much simpler. So color, and then builder append. I guess it's the color to string, the stuff from here, and then we'll continue. Okay. And then inside of the div, we want to have a span that ends somewhere. It's this span here, and we want to have some text inside it that has this text. So this one we can create up here actually. A timestamp string. And what we're going to parse here is just builder to string. And here we'll append the timestamp string. I mean, this is looking pretty understandable so far, right? Then we want a B element. And I want that to end. We don't need all these calls to append, by the way. I'm just doing them because it looks kind of tidy. We wanted this here to be the nickname text, so I guess we can grab that out here. Nick string. That, and finally we wanted a span with the rest of the text. I mean the message. Oopsie. Want that to end, and then finally we want the whole thing to be over. Like that, we're closing that div. And everything should be in the message element, which is the div. Yeah, right. So this could definitely be even nicer. In fact, maybe it would be fine to do this as one big append f. Let's try it. Like that. How do we do this in the nicest way possible? Like this. Yeah, this is clearly nicer than using append. And there we want the message. And then finally the div, and then it's over, boom. And of course, we can't just do that. So here we have to put the color to string characters and the timestamp string characters and the next string characters. Okay. And this could actually just be a string format, like that. And then the idea would be that instead of this thing, instead of this whole thing, we could just do m container element append child fragment. I guess we don't want to go, so document fragment, or like fragments in the DOM, it's a specific type of container node that can contain a tree like this, but then we would also end up with an invisible, or not an invisible, but like a document node outside of this. But it wouldn't be document, it would be document fragment, which would end, you know, down here. And I don't hate it, I guess. Maybe it's the best thing to do. I was thinking for simplicity, we could have parsing this could just give you back the div. But if we can do like we can append the fragment first child, which would be okay too. But for simplicity's sake, let's just say that it creates the div. So let's get rid of this. And then we can even streamline things here. Although let's not streamline too much because we might want to dump this out. Dump tree div. Okay, but API-wise, this looks pretty good, right? If we can actually do this. Maybe it would be cool to write it out this way. I'm just experimenting with what kind of coding style I like for this. This is very neat to me. Extremely neat. Okay. So let's make this actually work, because right now when we call parse HTML, it's going to produce a document, and that's not really what we want. Because we want to parse using an existing document. That's the thing here. So we want all of these new nodes to belong in the same document as the existing nodes. So I guess parse HTML fragment is what we're gonna, okay. I should just deal with the fragment thing. Okay, we are dealing with fragment. So here we'll have to pass in the document, so we'll just grab the, oh, we have m document actually. We'll do it that way. Okay, and then here we'll say document fragment. These should be allowed to fail, by the way. It's weird that they always return something. Const string view, and I think we don't need to take a URL here for Why did we take a URL here? Oh, we just called document set URL. Yeah. So that's not relevant when we're parsing a fragment. But we'll need to define document fragment. And I'm going to look that up because I don't remember exactly what it looks like. It's a minimal document object that has no parent. Blah, 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 lightweight document. Yay. And can I see the... Can't. Node type. I just want to know the node type number of it. Document fragment 11. Okay. Let's add it. Okay, we are officially adding document fragment. I was gonna have to do this sooner or later anyway, so I don't really mind like doing anything in libHTML because I know that it all pays off in the end. There's very little unnecessary work in libHTML at the moment. Everything makes it better somehow, I guess is my point. Document fragment node, okay. And then let's go in document fragment and just sketch this out right quick. And does it inherit from parent node? Or who does it inherit from? Inherits from node. Really? I would have expected it to inherit from parent node. Show it to me. How do you spec this? My good friends at the Watt WG. The node. All right. Why is this so surprising to me? Parent node. It's mixing. Oh. Okay, I'm a bit like out of date or like out of touch with how these specs work these days because I haven't been reading them for a long time. So maybe I should just not worry too much. Yeah. So document is a node, but document is very clearly a parent. So where do they mix those things in? Parent node. Okay. I don't know how this works right now, and I'm not going to try to find out. So we'll just go ahead and I'm just going to inherit from parent node, even though it's supposed to be mixed in. Because that's okay. Because I know a document fragment has children, and that's the point of parent node, is to allow you to have kids. Parent node, document and type, right. Node type. that. And I guess we don't really need much else. We can add one of those is getters. We have that here. No. Element. Just one of these things. So that we can distinguish. Okay. I think that's good enough for this at the moment. And then the important part is that we just have it available here. So we can just say class document fragment actually. Okay. Now, how do we implement this thing? So currently, the only way to parse HTML is to go through this thing, which is always going to create a new document. So we want to factor this apart, or refactor this, so that this assumption that we always create a new document goes away. So I guess we can have something instead like bool parse, static bool parse. HTML. And we'll say we'll take the document first. Or no. Let's take the document last. And we don't need the URL because that's just used here to set it up on the new document. Okay, so that's going to be this function. And then we'll have this can go down here, and this can go like this actually, and then we'll just call Parse HTML HTML and document. Full success. Okay, and then we'll just put this at the bottom so that things work out. And oh wow, this file is longer than I expected. Should have done this differently. Okay, here we are. And oh right, and then we have to do the fix up here at the end. And same thing with the insertion callbacks. True. And oh, that's this thing right here. Okay, so now we have factored out this code that will parse HTML and add everything to this document. And the first thing we do here is we append document to the node stack. So we can actually do this a little bit differently because we might want to not start with a document, obviously. So we should probably take like we'll take a parent node here, and we'll say root, and you can pass in your own root. And in this case, we'll pass in document as the root. But when we do parsing a fragment, HTML fragment, wait, why can't I autocomplete that thing? Okay, come here. Okay, we're going to need to include it also. Fragment. All right. And then it's an abstract type. Oh shit. What did I forget to implement? tag name. Right. And how does that look again? Tag name. Let me just do something like that, just so you can see what it is. Oh, and we'll take the existing document here. Right. And then we're going to do this same thing. Parse HTML, we passed in the document, but now we pass a different root. So that this fragment will be the root, the new node tree that we built. And we assert that it worked out. And then we return the fragment. I feel like if it doesn't work out, we should return null putter, and then people should deal with that. But at the moment, we don't. Let's do the right thing here. So if null putter, all right, that's what it should look like. So who's using this? IRC log buffer, right? At first, I was kind of thinking that we'd be using like set inner HTML on this, because I was thinking about how in like JavaScript you might do something like you know, foo.inner HTML plus equals div and so on. But the whole plus equals part, that's actually pretty shitty, because what that ends up doing in like behind the scenes is that first it has to serialize everything that's in the DOM in this foo element. So it serializes the whole DOM and then into a string, and then you append to that string some additional DOM elements that you want to instantiate, and then it has to parse that whole thing. So this is actually a really, really inefficient way of doing things, because you do a lot of the parsing work again and again and again. And I think this is much, much better here if we can only parse this small fragment and then append that here. But I'm thinking that we should probably just grab the first child of the fragment and then let the fragment die. And we should steal the first child of the fragment, actually, somehow. How do we do that? I guess auto, or let's say ref putter to element div equals to fragment first child. No matching function, because I have to pass in the HTML and document. Oh, it's the other way around. That's really awkward though, because then I have to put the document at the end. I prefer just having the string formatting stuff like this. Let's change this API. Like that. Okay, that's better. And oh no, we already had dump. We don't have a dumper for a fragment. What do we have dump tree versions for? We have dump tree for node. Well, what is a node? Why can't we cast like that? So ref pattern. Oh, it's an incomplete type. I'm stupid. So there was no need for the cast. We could just do this, like the way that we originally did it. Okay, and then from node star to element. Yeah, right. So let's just do it that way. Fragment, remove child. Something like this. And why does this not work? What's wrong with append child? Oh, it needs to be a... You can't append child null. And there is no remove child, so we have to implement remove child. Well, we can do that. Call, I guess this one will be remove from append child. So how does this look? Oof, this is a bit chunky. Well, I guess we'll just write it out. And we don't need to have a ref footer to the node here. Although it does actually, doing this actually gives us some like safety for free, because this means that this thing will keep the node that we're removing, it will keep it alive until we exit the scope of the function, just by virtue of this argument always being a reference counting pointer to node. So it means that we can't like mess up inside of this function and accidentally delete it early, which will be nice. Call removed from. Okay, then we'll assert that the node has a parent and that it is me. And then I guess we'll say, now you don't have a parent, bro. And we want to, let's see, removing a child doesn't mean that we remove its children, but we will definitely remove its siblings. So if node m next sibling, sibling is no better. I mean, actually, we know that that's okay to touch these. So yeah, you're no longer siblings. You no longer have a parent. And if call removed from node removed from, we'll do this, and this is just to give it a chance to react to this, and then finally we will deref the node. Because currently the way the tree node works is that the tree references all of the nodes inside the tree. So you can see here that we leak one reference onto the tree, or we leak one reference on the node when we append it to the tree. So now when we remove it from the tree, we have to make sure that we dereference it or unreference it. Sometimes I wonder if deref should be called unref instead. Because deref is a little bit overloaded of a term, I mean. Bye. Right, and then we gotta update, potentially update the first child, last child pointers. So if, let's do those first. If m first child is node, then m first child is node next sibling. if m last child is node, then child is node m previous sibling. I feel like I'm missing something super obvious here. But you remove from the head, from the first child, then your next sibling becomes the new first child. And you remove from the end, then your previous sibling becomes the new end. More makes sense. Okay, so let's look at these inserted into callbacks. Where are those? Here. Oh, see, and I've already been here and added remove from because I knew I would want it eventually. Looks like, yeah, right. I was a good boy, thinking ahead. Get rid of this. Let's see if this whole thing just built. Wouldn't it be nice if it just worked? That would be amazing. This here feels like a little bit of a, you know, we're rejigging a little bit recklessly. It would be nice if there would be some slightly more straightforward way of doing this. We can probably think of some API for this. IRC log buffer, line 38. Text is not used. Oops. Oopsie doopsie. I'm forgetting to pass in the frickin' thing. The text dot characters. Oof. Why does it suddenly do that? I don't like that. Oh wait, there's no comma. Okay, I don't know why it suddenly wants to format it that way instead. I don't appreciate this Clang format. Why are you doing this? This was pretty good. I'm just not going to touch it at the moment. Why are you this way sometimes? Clang format. Jeez. Is this really how you want things to be? Probably. Maybe this whole thing would go away if we set like a limit on the line length. But at the same time, sometimes you want long lines, but in this case you don't. Why don't you do what I think? Just do what I think, Clang format. Okay, so let's just bravely go in some IRC channel and see what happens. Come on, join the Serenity channel. Come on, auto join. Doesn't that work? Oh, there we go. This looks weirdly good. The hell? Makes me wonder if we're even running this code. So I feel like this was supposed to dump something out. Oh, maybe we didn't actually do this particular. Oh shit, yeah, right, because there's a whole other add message down here. So this one is only when you get a message from a nick. All right, let's say something ourselves. And because of that, I can't even type. That's how broken things are. Oh, okay, I don't know. Hi. It's not exactly right. So hi ended up bold because I guess maybe I screwed this up. I expected this to come out as a DOM tree here. Div span b span div. So here's the color, here's the timestamp, here's the nick, and here's the text. Let me grab my hello me. Let me grab my IRC client over here. It says hi. We'll say hi to him. Okay, so this is definitely not doing the right thing. Let's see that we are let's see what we're producing here, and let's also join a different channel next time so that we don't spam people. We'll call ourselves Mr. Tester, Mr. Testerman, and we'll join Serenity as test. All right. Okay. And then let's put this in an HTML string. Okay, I'm gonna put this up here maybe. Oh, we can look at these here. Oh, crap. Oh, I see what the problem is. This is definitely confusing it. Right, we can't just be using these type of things here in HTML. What am I, silly? They have to be LT and GT. What a silly problem. That's funny. So obviously these nicknames look like tags to HTML parser because they would like Clang, hello. What did I think would happen? All right, Mr. Testerman. Okay, it's looking a little bit more like I expected. And come in my test channel, please. Aha. Well, hello, Mr. Testerman. Okay, that's awesome. It totally works. Okay, let's do this for the other message thingy as well. It's really weird that we have two variants of this, because the difference is just that in one case we have a nickname and in the other one we don't. So maybe this one could just be like, if there's no nickname, then but you know, for now, let's say that we update this function to do the same thing, except without the nick. So be gone and be gone. And like that. And this makes me feel like there should be some kind of libcore API for like see date time now string to string, something like that. That would be nice if there was such a thing. There is no such thing. Okay, so what can we do with this stuff? Does remove child normally return the removed child? I forget. Let me look that up. It returns returns the removed node. Right. Okay, so let's make it do that, because that will allow us to do something really sweet here, like fragment remove child div. Boom. And we can do fragment remove child, fragment parse child. Boom. Wait, does that work? Yeah, right. We have to actually. Okay, we have to make remove child do the right thing. Remove child should give us back the child. Non-null ref footer to T, and we will just give it back to you. Return node. Yeah, that's okay. So then this becomes, yeah, so the container element append child, fragment remove child, the first child. It's kind of strange, but it does work. I think it does work anyway. Okay, and this time string thing is annoying to me. Timestamp now, no string, something like that. I'll just do that and that, and then we can okay. Now we are cooking with, I don't know, olive oil. And come on, Mr. Testerman, come back. There we are. Hi, dude. Very nice. And of course, this one here did not have a nickname, so this is actually taking the other path. Because the ones with nickname, they have the nickname in these tags, as I guess I would normally call them. Although in this case, they're specifically not a tag. It's very cool to me that this is HTML now. It's still not really over that. Okay, so I have to admit I am very happy with how this has turned out. This is clearly so much better than what we had before. So let's make some commits out of this. Can get rid of the, can skip the IRC client any change, because that was just to avoid spamming people in the channel. Let's see, when we remove child, yeah, let's add that one separately. Lib HTML. Remove child. That's a child. from the tree. And returns it wrapped to the caller. Yeah. Oh yeah, right. It's calls moved from with the parent if it's optionally, but by default. Yeah, on the child. That's pretty cool. And then we did we added document fragments, so let's do that. I mean, no, we can do that as a separate command. That's okay. Document fragment h. Oh, the CPP file, I guess, is empty actually, so we didn't need to add it to the makefile. Makefile shared. We don't need you yet, so. DOM node. Okay. Additional add document fragment. All right. Now this is just a simple parent node subclass with its node type being document fragment node. Okay. And then, oh, we did the parsing stuff. So HTML, parser, HTML parser, CPP and H. Add parse HTML fragment. This function parses a fragment intended for an already existing document. And to both parse HTML and parse HTML fragment. Maybe we should rename actually. I'm gonna amend that commit. So let's rename parse HTML. Or should we rename parse HTML? I feel like we should, but it's a big change. I feel like we should rename it to parse HTML document. We'll do it in a separate commit. Now two entry points, entrances into the HTML parser, one for parsing a full documents and one for parsing fragments. Internally, they share these wrap the same function. Okay. Parses a fragment. It parses a partial DOM and returns it wrapped in a document fragment. No, it's document fragment. Okay. I like this better, Parse HTML document, because then it's clear that one is one and one is the other. And I feel like maybe we should make Parse HTML document return a ref footer instead of a non-null ref footer so that we can allow it to fail to parse. Oh shit, that's a lot of changes. I don't want this one. I almost renamed it to Mr. Testerman. Okay, I like that better. And then let's see about making it return a ref footer so that we can indicate failure by returning a null. Plop. Okay, and then here, if it fails, if arse document, return null footer. Right. So, I mean, currently this doesn't have a way of failing. It will just happily give you whatever it produces or assert. So failure is a future state to introduce, but at least now this will force the clients to deal with the potential for failure, so they don't get comfortable thinking that, oh, this will always return a valid object. It might be that we're fine, that we were not even assuming that to begin with. It looks like it compiles. So I think we're still in the clear. Yeah. So none of the clients were written assuming that it would return a non-null ref footer. It's great. And browser still works. Awesome. Cool. So let's see. See if we can connect. Hello, supercomputer. All right, so he's there. He's looking good. Let's say something. Hi again. No, I'm gonna just say hi. 2. Okay, now this is looking the right way. Well, hello, supercomputer. Cool, so this is working just the way I wanted it to. I'm pretty happy with these changes. It's nice to work on libHTML. Oops. Nice to work on it without necessarily just being for the browser, but this is more for the use case of being an embeddable UI component, which is obviously a very important use case. So yeah, that's cool. Let's go look at that API usage again, because this is so neat. So very, very neat. So this is going to be it for today's video. And I hope you saw something interesting here. And I thank you for hanging out. I will see you next time.